I'm aware. 2 minutes. Yes.
I'm third, like 2 seconds. Yeah.
Uh-huh. Yeah.
Oh my god.
Yes. For anyone listening to this, if you live in the city of Cincinnati or a metropolitan suburban, sign up for Google Fiber. That'll be on YouTube. All right. So, the second half of this, I wanted to kind of go through. Did anybody actually attempt to do the file save or file open? Did anybody do it successfully? All right. 3 for 3.
I think I sent you the wrong like moment though.
That's fine. You can submit it again.
Okay.
Is it alright if we did some online research and modified the code and put it in ours?
You, like, looked stuff up
Yes.
and did stuff?
Yeah.
I guess that's okay. You're allowed to do research and figure stuff out.
The internet. If it wasn't for the internet code, it would be so much harder.
It would be.
Has to be stuck on Hello World.
Yeah, even like when you're doing like theoretical stuff and like math, like MIT has like all of their computer science courses online.
Mm-hmm.
Coursera has like everything you need. We're doing an introduction to database course and a differential equations course on Coursera.
Yeah.
That's awesome.
The one thing that I always say about copying code, and I'll just make this statement now, is I find myself copying code rarely but occasionally. But if you're going to copy any chunk of code, as long as you understand what the code does, I don't care. You saved yourself some typing. If you can't explain what the code does, then don't use it. Because that's theoretically the exact same thing as I picked up this black box, I don't really know how it works, but I plugged it in my code and it makes it do something. I've run into people that I work with where they go, I don't know how it works, but it works. Which is fine until it stops working the right way and then you don't understand why. So that's my only recommendation is if you find some code that you don't understand, I'm not saying that you can't use it, but you need to go back and learn how it works. So if you copied code from the internet to get the file open and file save to work, that's fine, but I hope that you did the research and went back and learned what do these methods do, what do these classes do, how do they work, what options are there to make them work, because that's where you're actually going to learn something, and then the next time you run into the problem, hopefully you'll go, oh yeah, I need to use a file stream. Oh yeah, I need to go do this. I need to go do that.
I had to modify it a little bit, so I kind of had to understand how.
Okay.
Trial and error.
Right, and I'm not trying to attack you about it. I'm just standing on my soapbox as a teacher and saying, don't copy and paste code. And I've even helped students with other projects in other classes. I don't know why they bring me their Java work, but they seem to think it's universal. So, and they'll come to me with code where I have a rough understanding of Java, and I go, what is this doing? And they shrug their shoulders and look at me and go, I found it on the internet. Fabulous. So, I digress and get off my soapbox. Alright, so, file open, file save. I'm going to drag an open file dialog and a save file dialog down to my tray. So I now have those controls to use. We'll start with file open. Just like last time, pretty straightforward. We're going to capture the dialog result. Or we're going to capture that dialog result via the open dialog file dialog 1. We'll say show dialog. Actually, I'll do that as dialog result. Alright. So this will open the dialog and capture the user response. And then we'll do a, if they choose OK, open the file, else do nothing. right? Pretty straightforward. So if the result equals okay, open the file, else do nothing. We'll just let the dialog box close and we'll go on our way. Now, opening a file or reading a file in requires a series of steps.
Like a reader or something.
Right. So you have these elements that are called streams. You have file streams, you have memory streams, you can have network data streams, you can have XML data streams, you can have TCP or web streams, socket streams. I forget all the other streams, but there's a lot of streams. These streams allow you to push and pull bytes of data from the system. So what I always recommend doing is starting off by validating the file, attempt to open, stream the data, close the stream, and then load the data into the box. Okay? So we'll create a string, file name, and we'll set it equal to open file dialog 1. And then you'll notice in here that we have two properties, file name and file names. I believe, yes, there's a property called multi-select, and I think it might have came up last week, I don't recall now. You can have a file dialog box that allows you to select multiple files. So that's what the nuance is between file name and file names. Name is a single string, names is an array of strings. Technically, the file name, the singular, will exist inside of file names as a single indexed array, so one position. All your personal preference. Ideally, if you think about code reusability and lack of having to touch your code, if at some point you think that you might need to do multi-select, my recommendation is write it so that you're always dealing with multiple files and simply toggle that on or off. Write it as if you're going to deal with multiple files and then set multi-select off. So you're only going to deal with one file by the limitations of the dialog box. But if your boss comes to you in a year and goes, you know, it'd be really nice if I could select multiple files. You go in and make it true, recompile, boom, you're done. So those are some of the things that you need to consider as you're developing is how much work am I going to put myself into if I have to go back and make this adjustment. And I don't always get caught up in that, but that's kind of that architectural decision you have to make from time to time as you're building things is which path may take a little bit more up front but will save me a lot of effort later. So, things to keep in mind. For the sake of class, we'll do a singular. Now, inside of the system.io namespace, you have all of your basic I/O, which I will summarize down to the statement of file functions. Now, there's obviously more than just files in here. You also have information around the file system, so directories, drives, file. There's also information in here, a finite amount that has to do with isolated storage, mapping files. You can do memory streams, which allows you to basically create a memory resident file, if you want to think of it that way. So if you pull all this data off the internet, you need somewhere to store it temporarily, you don't want to write it to a file, you can stick it in a memory stream. You can hook streams together. So you can hook an internet stream, a TCP stream, up to a memory stream and stream all the data from that TCP traffic into that memory stream. Or you can stream it down to a file, or you can stream it wherever you want. But these streams are kind of interconnectable, so you can pull data between them. You got paths, you got pipes, you got ports. And then there's all your stream options. So you got a stream itself, which is the, generic element. You have a stream reader, a stream writer. derivatives of those are string readers and string writers. So if you have a element that is nothing more than strings, text reader and text writer. Then you have unmanaged memory accessors, and then you also have the file watcher, which is kind of a slick little class where you can say, look at this file, look at this directory, and whenever an event or whenever a file changes, gets updated in there, it'll trigger an event. Concrete example, one of my little side things that I do is I work the stadium at our high school. I do the scoreboard. And for a long time we would have to take the stats from the game. We had a different set of guys that sat in a different spot in the booth that would do all the stats, the down and distance and so forth and so on. And we would ask them to run off for us stat sheets. We would take those stat sheets, we'd key them into the scoreboard software, put them in the positions, blah, 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 and then we have to push them up to the scoreboard so that people at the game could actually see the stats. Well, that got to be a big pain in the butt because every 5 minutes we'd have to run off a new sheet, and then I'd have to go in and I have to type it in, and I was like, this is way too much monotonous work. I can't watch the game. So, instead, I said, every time you run me one of those sheets, where does that data go? And they go, oh, I don't know. So I started digging around, me and a buddy, and we found that every time they run that sheet, the software compiles the stats and writes them to a text file and then spits the text file out on the printer. So what I did is I wrote a little console app that runs. We mapped their drive to that computer. It then looks for that text file. I use the file watcher, and every time, so every 5 or 10 minutes or after every so many plays, they hit the button to generate the file, but they don't print it. The file watcher watches for a new file, picks it up, parses it, and then preloads it into the software for us. So instead of having to do that work, I wrote a little app that does it for me. So file watcher is kind of a slick little piece that it gives you that ability to watch the file system on a computer. When something happens, it triggers the software to go in and pick up that file and do something with it. Now you may be thinking, well, I can just write a loop and just constantly check the date time on that file. You could do that, but you'll end up locking up the computer doing it because it'll be in this constant loop where it gets stuck. The file watcher does it asynchronously so that it doesn't lock up the entire computer while it's checking for that file. Alright. So in this case, what we'll want to do is we want to use the file class, and it itself is a static class that has a whole slew of different methods. The one that I'm interested in is the exist method. So I can pass it in the file name, and I can say if the file doesn't exist, so not file.exists, show message, sorry, message box dot show no file found, return, and exit the method. Ironically, that should never happen, but there is always the likelihood that you go in, you select a file, you hit OK. At that very moment, you're accessing a shared file, somebody else deletes it, and then all of a sudden the file doesn't exist. So your app blows up. So doing those additional checks and balances never hurt anybody. Alright, so then from that point, we want to open the file, pull the data out, and then put it in the box. So we'll start with a try-catch block. Is there any questions around what a try-catch block is or does? Hopefully that's pretty standard in terms of like what you did in Java. Everything that you want to try to do happens inside the try. If it blows up, then the code inside the catch catches it and gives you an exception object. A slight nuance difference between how things function in Java versus C# is that in C# you do not have to pre-declare what exceptions this method may throw. It's all implied. And furthermore, you can capture all exceptions by simply using this catch statement. If you want to capture unique exceptions, you can actually daisy chain these together. So this block will catch all I/O exceptions. So any exception that is of type I/O exception. This will catch all application exceptions. And this is basically a catch-all for everything else.
I think in Java we had to specifically say like IO exception.
Yeah.
Like that. It was kind of specific. How
Yeah.
you wanted to catch it.
Yeah, so this isn't required, but if you want to handle them differently, you can capture the different exceptions in the different ways. Generally, for myself personally, unless there's a unique instance or a reason why I want to capture an I/O exception and handle it one way versus another exception, I usually just stick with the first option, and then I'll handle them all the same. Usually it's something to the effect of capture whatever message comes off this EX object and output it to the user, email it to to myself, write it to a log, whatever the case may be. Also, there is a stack trace. The stack trace is nice because it will spit out to you the execution path that got you to that point. Saving that out to a log is also nice because then you can at least get an essence of how did the computer get, or how did that user get to this point? What method did this exception occur in? And then you can kind of work your way forwards and backwards to figure out where that is. If you're running in debug mode, the stack trace is especially nice because it will actually tell you what line the error occurred on. Or at least what line of code was called when it went into something that threw an exception. So, very good to capture for debugging. So, here I will do just a message box.show ex error, and then I don't know why it's not giving my IntelliSense. It's alright. F6.
I had to put in ex.message.
Yeah, you're right. That was my mistake. So, there we go. Alright. So we're capturing our exceptions. So in the try block, we will start with that file class again. And we can do an open. And if you look at the signature of this open, it says that it will return to us a file stream, and it's going to require a string that is the path, the file mode, the file access, and the file share. Hang on one second. I feel like I hit some sort of shortcut key and it turned my IntelliSense off. So this will take the file name, take the file mode, and in this case what we're going to want to do is do an open. The file access is going to be read, because we're going to read the file, and then the file share is going to be read. Now these are very interesting. This in particular is very interesting because the file share tells other programs how our program is going to share that file. So if we say share none, it basically declines sharing of that file, which means that we have exclusive access to it and no one else can touch it, read it, write it, do anything to it. Share read says anybody else who wants to can read our file. Not a problem. Share write says anybody else can open our file and write to it while we're reading from it. Read and write means you can do either. And then the one that always boggles my mind is that you can allow other people to delete your file while you're doing stuff with it. So it's very interesting what these allow you to do. And then inheritable basically inherits. It has to do with the processes, and if you have child processes that are running, that they inherit the file access from the parent. So, in this case, you'll do read, and what that'll do is it will give us a file stream. We'll just short name it FS. So we now have a stream that's hooked up to that file, and we can now start reading from it. So we have a few options of how we can do that. We can create a stream reader, and that will take a stream or a path. In this case, we want to give it our file stream, and then from there we can take that stream and we can read from it. We can read an entire buffer of data, which basically means that this stream has a particular length to it. It's so many characters in length, or so many bytes in length. So we can read all of the bytes out, or a specific length of bytes. That's good if you're reading chunks of data as you go through, and maybe you put this in a loop and you're wanting to read chunks of it at a time. Read block basically does the exact same thing. The difference is that with the read method, it returns an integer. Read block is basically the implementation of the text reader, and it has a what's the difference? Oh, that's right. One's chars and one's bytes. Line read, we'll treat it as a text file, and we'll read a line of text from the file at a time. And read to end, we'll assume that again it's a text file and basically reads from beginning to end the entire file into bytes. Okay, or into a string. The string reader, or the read end? Okay. Peek will allow you to peek into the file and see what byte you're currently on. So in theory, you can actually step through this stream one byte at a time if you want to. There's an end of stream boolean, which will tell you whether or not you're at the end of the stream. And then you can actually get to the base stream object if you need to. The last piece that's a value, and this is a value whenever you're dealing with something that is an unmanaged type. And what it means to be unmanaged, let me first explain what it means to be managed. The .NET framework by design is considered a managed system. What that means specifically is they're talking about memory management. So let's go back to our C++ again. In C++, you have your heap and your stack. Everything that exists in the stack is part of the running application. It lives inside of the stack space All your variables that are declared, pre-declared, your integers, your characters, all of those live in the stack. So when the application starts up, pre-allocated space, the application runs in that space, and then when the application is done, it closes down and everything inside of the stack is then blown away. With the heap, you're dynamically allocating that space. You're calling out to the operating system saying, I need so many bytes. The operating system goes out and finds a memory address block, returns to you the first position of that memory address block, and assigns that memory to you. When you're done using that memory, you have to deallocate that memory, giving it back to the operating system. That process of allocation and deallocation is called memory management. You as the developer are responsible in C++ and in C and a lot of those earlier languages, you were in charge of managing your memory. You had to make sure that when you allocated something that you deallocated it, or otherwise you would end up with what we like to hear about that are called memory leaks. Equally so, you'd run into situations where you would allocate a memory address. In theory, another program could also obtain that memory address through their pointer, and then it could start injecting malicious code into your application. Both very bad things. You either end up with bloat or somebody hacking your app. Memory management was set up to essentially eliminate both of those problems. The way that the memory management works is that I declare a font variable in this method. This font variable has a lifetime scope of this method. So I declare it in this method. By the time I reach the end of this method, its life is over. Nothing outside of this method will ever see that variable new font. So, the runtime, the .NET Framework runtime, will watch your code and actually knows that when it reaches the end of this method call, this variable is no good. So under the hood, the framework will look at this variable declaration, it'll look at this line in particular, and it'll say, okay, you need to allocate memory for a font object. It will call to the operating system, say, I need memory for this font object, needs to be X amount of bytes, blah, blah, blah. Operating system says, here you go. The .NET Framework then says, here you go, this is your memory space for this object. Use it as you need it. Creates my variable, runs my constructor, sets my values, does my bitwise math, gives me the object. This is basically a pointer if you want to have the C++ parallel. It's a by reference object. You get down here, by reference, new font is passed into the selection font. You get down here, it then says, okay, you've used that object, it's over. It will automatically deallocate new font and give it back to the operating system because it's no longer needed. Your code logic no longer persists past that point for that variable. So it will throw that variable into what they call garbage collection, clever, where it will go out and collect all of the garbage variables that are in the heap that are no longer allocated. The garbage collector will then deallocate all those variables, giving the memory back to the operating system, which leaves you with a smaller application. So they're eliminating bloat because you don't have memory leaks, and because the runtime is doing the memory allocation for you, you're not accessing memory directly. You also have what's now called memory isolation. The runtime knows what memory it gave you, and when you try to access memory that it didn't give you, it will yell at you and throw an exception and say that you are attempting to access restricted memory space. Okay? There are certain elements of the .NET Framework that still run on the unmanaged memory space by design, by convention, because of how things work. One of those things is file access, because file access is managed by the operating system, Windows, Linux, Mac OS, whatever you want to talk about. were all written in assembler or C or C++. All of those require manual memory management. So in order for you to access the file system, it has to use unmanaged memory. Now, they wrap it up in a nice pretty wrapper, being the file class and the file stream, to make it easy for you. But there's one piece that always will stick out that you'll still see that you need to be aware of. And that resides on the class. It's a method. It's called dispose. And what dispose will do is it will dispose of that pointer, deallocating that memory and releasing that resource. So let's say that we created this file, or we opened this file, and we said none. No one's allowed to have access to this file except for us. We're taking exclusive access to this file during this open process. If we never dispose of our file stream and close it, no one else is allowed to use that file. You ever run into that problem where you try to delete a file and it turns around and says this file is currently in use? In theory, that's what can happen. The file is opened, it's not shared, deleting is not permitted, and it's currently locked by some process as a resource. So once you deallocate and release and dispose of that resource within your application, you're releasing that resource back to the pool. You're releasing that file to be opened by someone else. So, if we have our stream reader, we can read to the end. And then after we're done, we can do sr.close. And what this will do, if you read the description, it says closes the stream reader object and the underlying stream. So it closes both the stream reader and the file stream together. And then we can do sr.dispose. And then we can say fs.dispose. Now that can get a little monotonous if you're dealing with files a lot. So my alternate recommendation to doing this is that you can use a statement. It's a syntactual statement called using. Yes, using exists up here too. They're different. Using understands those conventions of dispose. And it's a nice, pretty easy way of always making sure that your unmanaged resources get disposed of. So what this will do is inside of this using statement, it will declare the variable fs. This line of code will run, and it will create the variable fs for you. When it reaches this, memory management takes over and goes, okay, that type is disposable. I will call the dispose method for you automatically, so that you don't have to make sure that you remember to call dispose. Now you may be wondering, well, how does it know to call dispose? How do I know that something has a dispose method? What does that all mean? If you click on this type file stream, and we're going to hit F1 and jump out to the MSDN, and I'm actually going to have to go up one to stream. So file stream inherits stream, right? If we jump back up to stream, stream inherits Marshall by ref object. And it also implements the interface iDisposable. Do you guys know what interfaces are? Do you know how they work? Okay. That's okay. So all I'm going to do is I'll go up here and I'll say iDisposable. think of an interface as a contract. And I'm going to touch on this in more detail later, but follow this idea for a minute, okay? So you have classes. And a class has all of these methods and properties and events and private variables and everything all packaged up inside of it. If you want to, you can inherit that class so that your class takes on those same attributes, right? An interface is a description of the methods and properties that a class should have, but it does not provide an implementation for them. There's no code to it. It on its own doesn't do anything. It simply acts as the contract or the blueprint for a class. So if you have a class that implements an interface, it has to implement the contract or the blueprint that that interface provides. So in this case, iDisposable says that you must have a dispose method. So by having a class implement iDisposable, and notice I said implement, not inherit, by implementing iDisposable, the class is required to have that method. So the using statement in our code looks at, with the help of Visual Studio in this case, looks at this type. Using reflection looks deep inside of it and says, do you implement iDispose? If it does, it says, great, I know I can call the dispose method. If it doesn't, it will give you a compiler time error saying, you don't implement iDispose, you can't use the using method, or the using call. Interesting enough, just on the topic of interfaces for a moment, is I can create a variable called toDispose that's of type iDisposable. Okay? I can then set toDispose equal to fs. And that's okay. So what's happening is that fs is an instance variable of FileStream. FileStream implements the iDispose interface. There's a commonality there. You can, just as if I were to say object, an object, I can say an object equals fs. That makes sense to you, right? Okay? fs can be cast to iDispose because it implements that interface. So I'm taking the object and I'm storing it inside of another bucket, another variable. That variable has a different mask on it. So if you talk about, so let's back up and just talk for a minute about what does an integer look like from the computer's perspective. The computer says this integer is 32 bytes of memory. It takes up this amount of space. There's a C# mask that's essentially put over top of that memory space that gives us length, size, and all these methods, right? All these actions that you can do on a number. That is that 32 bits of memory. FileStream is probably significantly longer than that because it's a stream of data. But it also has a mask sitting on top of it that says this long collection of bytes really looks like this. It has a fs dot, it has a canWrite property, it has a dispose method, an endRead, an endWrite, handle, position, length. You know, there's all these properties that get brought out of that segment of memory. Okay? Does that make some sense conceptually? Now we can put a different mask on top of it and say it's an object. So if we put a mask of an object on top and we look at it, well, all we see is toString, getType, getHashCode, and equals. Basic methods that you get off of an object. That memory space didn't change. It's still the same amount of bytes that was there when it was FS. But now it just has a different mask of an object on top of that memory space. So we don't see all the nuances and the specifics around that memory space anymore. All we see is that it's an object. Now we could come in here and we could say fs equals cast file stream an object, and we've changed the mask out again. We've made it a file stream again, right? Does that make sense? Okay, so that concept, do you feel at least somewhat comfortable with what that means? With this statement, toDispose equals fs, we're putting an iDisposable mask on top of that memory space. It's still a file stream. It still has the values and properties and methods of a file stream, but we're not looking at it through the mask or the lens of a file stream. We're looking at it through the let me pick one. Through the lens of iDispose. The only thing that you see on iDispose is you get all the stuff from an object, equals, getHashCode, getType, toString, and that one method called dispose. Okay? So now here's a little bit of coolness that can happen. I could come down here if I wasn't using the using statement. I could say toDispose equals sr toDispose.dispose. toDispose equals fs toDispose.dispose. That totally rock everybody's world, or does that make sense? So I'm looking at both objects. They both their types, their data types, stream reader and file stream, both implement the iDisposable interface. I'm basically looking at both of them through the same lens, the same mask, and I'm just calling that method. So there's potential there, which we'll talk about later, that says to me, I can have two different classes that both implement the same interface, and I can treat them as if they're the same thing, when in fact they're two different class implementations. But they have this one commonality, this one contract, this one blueprint that they both share that is important to me. When you write plugins for programs, this is what they use. This is how they work. I, as the application developer, I always like to use Photoshop because people understand the idea of a plugin in Photoshop, a plugin that does something to your picture. If I'm Adobe and I'm creating Photoshop and I want to have this plugin functionality, I'm going to create an interface for your plugin. Because my application, Photoshop, doesn't know what your plugin does, but I need to provide a common interface for us to communicate across. So I'll declare an interface in Photoshop as Adobe, and I'll say that your plugin must have a renderOn method, a positions method, and a done method, or a done event. Okay? So then what Photoshop will do is it will take all of those bytes of image and it will stream them into the plugin using the canRender. Your plugin implements that same interface on the other side. Okay?
So your object becomes part of what you're interfacing to? Or
My object implements that interface. So then your program, your class, indirectly becomes part of Photoshop.
that's what I meant, yeah.
Yes. So then Photoshop passes through that method that you both agreed on contractually, that image in bytes. Your plugin then picks up those bytes on your side, does whatever thing it's supposed to do as a plugin, as a filter, and then says, I'm done, and passes back those bytes back to Photoshop, and then it puts it back on the canvas. So Photoshop doesn't know anything about your program or how your plugin works, but it knows that in order for you to be a plugin and actually work, you have to implement that interface. And when it interacts with you and works with you, it's not going to work with you and go, oh, you're this class, because it doesn't know that. It's going to say, oh, whatever class you are, I don't care, you implement this interface, and I'm going to talk to you across this interface. Just let that stir in your minds, because we'll get to it again later, but I wanted to at least give you kind of a 50,000-foot view of it. So what really needs to be taken from this is the stream piece. Okay? So we go in, let me get that out of the way. We declare a file stream. We open that stream to that file. We then take a stream reader so that we can read the contents of the stream. We read it to the end, so we start at position 0, we read all the way to the end, read that out into a string, and then we can take that string text equals file text. Yep.
What if it's not a text file? Like, what if you just choose like a picture? It says read to end. What would happen? I might have said default to .txt, so it doesn't have to read it.
Sure.
What happens?
Had you ever tried to open a JPEG in Notepad?
No.
Really?
No.
I'm disappointed. Anybody else try to open a JPEG in Oh, come on, guys. You've opened one? Right. So there's bytes in there. And what it will do is it will take those bytes. Let me see if I can find a picture.
Will it just show you like how it's represented in memory? Or?
Well, it's not in memory. It's going to take the byte. So, how do I want to say this?
It tries to interpret that
Yes.
bit as ASCII characters.
Yes.
Oh, okay.
If you're talking
Yes.
about a word reader.
I get it.
And try to match it up to an ANSI.
Yes.
Or an ASCII, sorry.
Yeah.
Like an ASCII scheme.
Right.
I can't.
Yeah. So if the first byte is 0001, it's going to take that and convert it. It's going to read it 8 bytes at a time.
Convert it to like a.
And then it's going to convert it into whatever character it matches up to.
So it's got a bunch of garbage.
Yeah, basically. Now here's something that's fun. Is in most. So this is a PNG. This is this graphic. All right. So it's doing its best to interpret those bytes as characters, like Chris said. You'll also notice that, and this is a fun thing for people that always end up with files and they don't know what the heck they are, try opening them in Notepad, or this is Notepad++. One of the, it's not a standard more as it is a convention. All files, or just about all files, the first, I guess it's the first 4 bytes, so the first 24 bits, is the file signature. So this is a PNG file. What's the first 4 characters in this? At least 3 of the 4. PNG. If you have a... What's this one? That's another PNG. If you open up a docx, and this is where it gets interesting, I'll open up this, and the first 2 characters are a PK. If you open up a DOC file, the first 3 characters is DOC. A docx file is a PK. There's another file type that also uses the signature of PK. Anybody want to take a guess? PKZip. Okay. So you know that docx, XLSX, and PPTX files are really just zip files? and inside of them is an XML document and all of your resource elements. Aren't you glad you came to class tonight? So if you look at this, there's the base. That's the root XML markup and references for everything that is that Word doc. This is the XML OpenOffice document standard. It has a different name now, but that's what it used to be. It's all XML based. You're no longer rich text. It's all XML. Your PowerPoints are all XML. The only thing that's not XML is the actual elements that you put in. So when you drag a picture in or put a video in a PowerPoint, those pictures end up going under the rels or the doc props and become zipped files inside of that PPTX file. So I don't know if you guys were old enough to remember, some of you might be, where you'd build a PowerPoint and you had to make sure you built the PowerPoint in a folder and then you put all your pictures and videos and audio files inside that same folder, because if you didn't, then it would break them when you moved it.
That wasn't that long ago. That was in high school.
Okay.
That was in like 97.
Right. So that's why, is that before they weren't embedded in the PowerPoint. They were linked. Well, now that they use zip, they actually will embed all of those elements inside of the PowerPoint file or the PPTX. It's fun now. If you ever have a chance, you should go back and find one of those really big PowerPoints that you used to have, the PPT files, open them in the newer version of Office and save. Don't change it, just save it as a PPTX. It will be smaller because it's zipped.
Tried. That stuff. It was like, it might have been 07, I don't know. It wasn't that long ago.
Yeah, anything prior to 2007 used the old style. So Office 2003 and prior.
That's probably what it was.
Yeah. So 2007 they released the DocX as the standard, and then everything from that point forward is compressed. So anyway, so to answer the question, if you try to read something that's not text in as text, you will end up with jargon. Basically, it will do its best to convert it to ASCII text. So I'll run, file open, I'll try to find some sort of basic text file, and there it is. So saving is the same but backwards, so we'll do that real fast. Grab this block, copy. We'll do file save, paste. So now we have to go in the other direction. So we're going to use the save file dialog. Then we'll capture the name of how and where we should save it. And then if the file, well, if the dialog box didn't do the work of making sure you want to save this, we would have to do it ourselves by making sure if the file exists that we check. In this case, we don't need to worry about that. So now we will attempt to create the file, and we will do a file open, the file name, and then we will do an open or create. So if it exists, we want to open the file and replace it. Or if it doesn't exist, we want to create it. Does that make sense? The other option is we can do create new. So you have to have write access, and if the file exists, you get an exception. So open and create is always a better one to choose. Create new, if the file exists, it'll blow up on you. All right. So in this case, our file access will be to write, and we probably don't want to share any access to it while we're writing to it. Sometimes you'll run into a situation where you want to be able to write to a file, but you want to allow other things to read from that file. So say you're streaming a large set of data, like a movie, for example. You're pulling it off a TCP stack. TCP stream, and you're starting to download that video file, that movie file, and you want to be able to watch the movie while you're downloading it, you can set your file access to write and your file share to read. And Windows Media Player, VLC, whatever you're using, can start to read that file. And it'll read from the beginning to the end as you're writing that file, so you can do both simultaneously. All right. So in this case, we don't want to stream reader, we want to stream writer. And we will give it the file stream. And then the stream writer has we have a write and a write line, both doing pretty much the same thing. Write, this is where I wish my IntelliSense would work. And go back up to MSDN. So you have a whole bunch of different overload options here for the write method. The one that we're going to look for and use is string. You basically pass in a string and it'll write that string to the file. So what we need to do is capture the text to be written. And it's really as simple as that. Now, one thing that you'll learn with streams is that there's one particular method that is of value, and it's called flush. And what flush does is it will take the bytes that you've written into the stream and it will flush them through the stream. And it's always good practice to run flush before you do a close or dispose, just to make sure that all the bytes that you've written to the stream are actually through the stream and down to wherever you want them to go, be it a TCP connection out to the internet, if you're uploading files to a server, be it you're writing it to a file and you want to make sure everything gets written to the file. Maybe you're serving up a web page and you want to make sure that all the bytes of the web page have made it out. Whatever that is, flush is always a good one to call. It only exists on writes. It doesn't exist on reads. Furthermore, another example of a flush where it's functional, JPEGs. If you ever create a JPEG file that's interlaced, is that right? Yes. Interlaced JPEGs, and you don't really see this that much anymore, but earlier internet, you would go to a website and it would download this really grainy version of a picture, and then you would see it gradually get clearer and sharper. And what was happening is that the server would send the first so many bytes of that image, which was that really grainy version, and it would flush those bytes to the client. The client would read them, render an image that was shoddy. It would then push more bytes and flush those to the client. The client would capture those bytes and then re-render the image with more bytes, and then it would continue through that process until you received all the bytes, and then eventually you would get rendered out the full image at full quality. So that is another use of the flush, is to ensure that you're pushing bytes to your client or to your source as need. So, all right, so we'll save that. F5. This is my first WordPad. Save. Testfile.txt. Save. And there's testfile.txt. And there it is. Simple as that. Now, out of my curiosity, bold and italic, save, test file 2. It stripped all of my formatting out. So you have two options on how to approach this. What we're doing is we're treating it as text, and it's stripping out the formatting. We can take our text and we can encode it into bytes and write the bytes to the file. So to do that, let's see, this is the write. So what we're going to actually do is before we get to the point of writing the bytes, and we actually don't even need the stream writer for that, is that we will use the system.text .ASCII encoding class, and we're going to create ASCII, or do I want to do ASCII? I think I want to do Unicode. Alright, so with the Unicode property, which is an encoding, what we'll pick is get bytes. And get bytes, there's a lot of overloads for that one too. There should be an overload here that takes a string. And this overload will take in a string, which will be our text, and it'll return to us bytes, an array of bytes. So what we're going to have to do is from the rich text box, we'll want to pull in the RTF values. And get bytes will actually spit out to us a byte array, which we'll call the buffer. And in the file stream, we can go to position 0, start at the beginning. If this file already existed, it would end up appending to it, so we have to make sure we go back to the beginning of the file. And then we'll say file stream write. And then it takes in a byte array, and it wants an offset, which is the starting position, and a count, which is the number of bytes that it should read. It should read from the array. So we'll pass in the buffer. We'll start at 0, and then we want to go to the length of the buffer and write all of those bytes to the stream. Then we will flush, and it will, using the using statement, close and dispose. So now if we refresh, bold, italic, save, test file 3 dot, I'm going to save it as a txt, and you'll see that it spit out characters, but it's the RTF encoding. Now, technically, what it's probably done, if I had used the RTF option instead of the text option, we would have gotten the same result, because it gave us this string. Does that make any sense to anybody besides me?
Say it again.
So what I did in here is I took, before I was taking the text property. So what it was giving me was it was stripping the formatting off and just giving me the string. So when we saved it out using the first method, we were actually saving the stripped text, which is why we were only getting text. If I had done the same thing, but had used the RTF, I could have used the RTF. It would have kept that. It provides the formatting in text. So it would have worked either way, or provides it as a string, so it would have worked either way. So that's a relatively bad example. But if you were to maybe create like a painting app and you wanted to save that file, that painting, to a file, you would use this method to stream that file, those bytes, to that file. So this is a more exact interpretation of how you write bytes to a file, is this method that you're seeing now. The other way is a more streamlined version if you're pushing text. So then if we go back and we tweak this one, and I'll do a short tweak instead of the full one, we should be able to say here that this is an RTF. So if I go File, Open, Test, File 3, maybe not. That's fancy. So what it actually did, that's why. Alright, so interesting. Okay, so here's what's happening. Type text into my little WordPad app. File save. Right? Type some text. File save. Sample file. .txt. This sample file is being Unicode encoded. Not ASCII, but Unicode. ASCII's 8 bytes in length, or 8 bits per byte. No, 8 bytes in length. 8 bytes per character. Unicode is 16 bytes per character. Up here, when I'm using the stream reader, it's decoding it as ASCII, which is giving me a completely different set of characters. So there's one of two solutions here. Right? Yep. Which means I have to save my file back out again, but close, do a .txt on the end. So there it is. If I come back in here, do an open, not there, F5, open, sample file ASCII, and there's the text again. So the encoding makes a difference when you're making sure that you're coming in and out the same way. If you encode it one way and decode it a different way, you will get different text. So, magic. All right. So I think at this point, I'm going to stop. It's enough fun for me for one night. I will post the homework probably tomorrow. It'll just be kind of a run through like a lot of them have been. I'm debating on giving you an assignment of creating a GUI calculator. So taking similar concepts of what you did with the command line one adding to it the GUI aspects of the buttons and all of those things. And then I may even give you the additional assignment of taking what you learned in the command line one and bring it into the GUI one, so that I can go into the text box and type in an equation and then have it spit out the values. You can start to learn where the what.
Would you want us to include like all like order of operations, like parentheses and exponents too?
No, just I would say at most what we did in class that day.
So
So
it's like 2 times 4, 2 plus 5.
right, but I want you to be able to do the 2 times 2 times 2 stuff.
Okay.
So I want to see that, but you don't have to do the whole super order of operations and parentheses and all that. That's not the point of this class, you know. So I think that will be the assignment. So just replicate something like that, get a better sense. One piece that I'll document this in the assignment details, I want you to do is try to create one event handler for all of the numeric buttons. So last week we talked about how do you create one event handler, one method, and tie it to multiple controls. Because realistically, you shouldn't be creating, how do I do 1 this way? How do I do 2 this way? How do I do 2, 3? I mean, it should be the same mechanics. The only thing that's different is what is the number on the button. So that'll be the challenge, is think through that process a little bit of how do you work around having 9 event handlers for 9 numbers or 10 numbers. So that'll be the homework. Not too challenging, but enough to kind of make you think a little bit. Okay? Cool deal. Have a good week, guys.